Welcome to VINDAL'S concept, and today we want to talk about this current electricity and this calculation. They say we should find the potential difference across the 20 ohms. So the voltage across these 20 ohms, that means what quantity of energy is this 20 ohms taken away from the battery in this circuit. That is just what it is. The PD across 20 volts. As the current starts flowing in this direction, when current gets to this point, let me call this point A, something will happen. The current will divide themselves. Some current will flow through this point. I will call it I1. There is a current flowing through this one. This is already 2 is given. I2 is 2 ampere. So when they get to this point, point B, they will all come out again. So the truth is this. The only problem I have is that I know the current flowing through this part. I don't know the current flowing through this part. Now, for this current to come out at B, it must be this current plus this current. And the principle I'm applying here is Kirchhoff principle. There is a principle called Kirchhoff. This one, this is called Kirchhoff current law. Maybe Kirchhoff, however, Kirchhoff current law. So he says that the current coming from the battery, the conventional current flowing through this part, that the current flowing into this place, the algebraic sum of current into a point or into a node or into a junction is 0. That means the one flowing into this place must be equal to the one flowing out. The same thing happens at this point. The current flowing through this point will go through this place, comes down to this junction. This one flowing through here will also flow here, goes here, and come out to this junction. When it comes out, the two of them will join together and flow out as a single value current. So what is that current? I will call it I, which I don't know. If I know this current and multiply it by this 20, I can get this voltage. Let us use a simple algebraic expression, which says that algebraic equation, we say that I1 plus I2 is equal to I. Look at what I mean. The current flowing through this place plus the current flowing through this place is equal to the current flowing through out. Is current flowing out. Now, I know this one. I don't know this one, but I know this one. I don't know this one. Therefore, this current is I1 plus I2. Now, one other thing, remember this resistor and this resistor, they are parallel. But I can find the voltage across this point. The voltage across this point, V1, is just 2 times 5, because the current flowing through here times this one is 10 volts. Now, if 10 volts is flowing through 5 ohms, then if 10 volts is flowing through 5 ohms, 10 volts will also flow through 10 ohms. Why? Because parallel resistors have the same potential difference across them, period. Therefore, 10 volts is equal to I1 times 10. What I mean is the voltage across this one now, let me call it V2, is current times this, and that is 10. So I said that I1 is equal to 10 divided by 10, which is 1, which is 1 ampere. Therefore, the total current flowing out is going to be, because from here This I1 is 1 ampere. 1 ampere plus 2 is going to give me this. Therefore, total current is going to be 2 plus 1, which is what? 3 ampere. Now, if 3 ampere is flowing through this place as 3 ampere, then this 3 times this is going to be that. Therefore, the V is going to be 3 times 20, which is going to be 60 volts. Thank you, but remember you need to subscribe, like, and share. At least give us a good comment. It will encourage us for more. Thank you.